Hi, this is Matt Oliver from the University of Delaware, and I am one of the many ocean scientists working on Project Swarm. In our introduction video, we thought about food, which is one of my favorite things to think about, especially food in a grocery store. And we wondered, how did all this food end up here? Is it because the local grocery store is right next to local farms that can supply it with wonderful food? Or is it because the grocery store gets its food delivered from far away farms using trucks and rails? Well, near Palmer Station in Antarctica, we also have a really rich grocery store called the Palmer Canyon Hotspot. There, the customers are the Adelie and Gentoo penguin, and the food is Antarctic krill that can get moved around by currents. In Project Swarm, we have 4 major hypotheses that we want to test. And to test these, we need to use all kinds of different technologies. In this video, we're going to talk about how to measure surface currents that may be transporting and concentrating krill. This photo shows how currents can concentrate ice in certain locations. We think this is important for krill as well, the main food for penguins. To measure the surface currents, we need to install antennas at Palmer Station and at remote islands. They are the Jubins and the Warriman Islands seen here in the red dots. To get to these islands, we use little Zodiac boats. And once we get to the islands, we tie up the boats and unload the cargo onto the islands. We then drag the cargo up to the site that we want to build, and it can be tough work. We need to make sure our equipment is secured to a rock, not to snow and ice, and therefore we need to dig under the snow and ice to get to the rocks. We need to dig a lot. It can take a long time to prepare the site for an HF radar station. Once the site is clear, we can assemble the remote power station that powers the HF radar. It has wind generators and solar panels to make sure we have electricity to make our measurements. Inside these remote power stations are computers that control the HF radar station. We need to make sure they're operating properly. It's hard to visit the remote power station, so we need to make sure it's secured to the rocks and providing power to the HF radar antenna. This is what an HF radar antenna looks like. It sends out a radar signal over the water and measures how the motion of the water changes that signal. We then use small boats to drive around another antenna that calibrates the HF radar antenna. It is a lot of work to set these up. HF radar is a Doppler radar. It operates based on the principle of Doppler shift. It is the same principle that the police use to measure how fast cars are going, or how weather radar measures the movement of rainstorms. HF radar data measure how quickly water is moving toward or away from the antenna. But having only one antenna doesn't give us the direction of the current. It only measures the component of the flow that is flowing towards or away the antenna. We need at least 2 HF radar antennae to see how the water is moving. So if we have a measurement coming from Palmer Station, we need at least one other measurement from another HF radar station that gives us the true direction and speed of the water, shown here by the black arrow. We can do this all over the place. And every hour, we get a map of the currents over Palmer Station hotspot that looks like this. We can see the complex currents moved by the direction of the arrows. The color under the arrows correspond to the speeds of the currents. We can see places where arrows are pointing together at each other. These are convergent zones that may be concentrating prey resources for the penguins. Once we have the current measurements, we can simulate how particles or krill might get concentrated or dispersed by the currents. This is an image of particles, virtual particles, that have been sprinkled in an HF radar system, and now the currents can move them around. The red dots that you see are the locations of actual foraging penguins. So this data is made available to you guys via a file that your teacher can show you. So the HF radar data that is made available to you by your teacher is going to look something like this. It may be an Excel file or on Google Docs, but it's going to have 3 or 4 columns of data. One is the longitude, or the east-west location of the current measurement. One is the latitude, or the north-south location of the current measurement. You're going to have the speed or the velocity in units of centimeters per second, and the compass direction of that. And in fact, you can take a look at what the data is that you're going to look at here. This is the actual data that is in this that's in this file. So this is the metadata tab, but we can also click on the data tab and see the longitude, the latitude, the speed, and the direction of those currents. So these data here are represented by this figure right here. This one data slice, or HF radar, is taken January 1, 2015 at midnight, but we will provide you with other files that you can play with as well. As always, there's a team studying the physics, the phytoplankton, the krill, and the top predators to help you guys out. Please help us answer our hypotheses, or work with the outreach and education team that we have to answer your own hypotheses. We look forward to see what you can do with this data in Project Swarm.